We will go for the fourth experiment, that is an experiment on 555 timer, that is an astable and monostable multi-vibrator. Okay, so first we'll try to understand what is the aim of the experiment. Okay, so the aim of this particular experiment is to design and simulate an astable and a monostable multi-vibrator using an 555 timer. Okay, so once again we will not discuss much about the design, so that we will concentrate on the other theoretical explanation session. So in this we will be more concentrating on the simulation aspect of the circuit. So this is the circuit diagram for an astable multi-vibrator. Okay, and this is a circuit for our monostable multi-vibrator. Okay, so we know our problem statement, the design. Okay, so this is for an astable multi-vibrator. So we want an square pulse, I could say, whose frequency has to be 1 kHz and its duty cycle is 0.6. So this is what has been given in our problem statement to design an astable multi-vibrator. So using some standard equations, so we are able to compute what's the value of Ra and Rb. Similarly, for a monostable multi-vibrator, so he has defined what is the pulse width as well as, I could say, the frequency and the duty cycle. So this is a simple design for a monostable multi-vibrator. Okay, so this is a simulated circuit which we are going to re-simulate on a multi-sim simulation platform. Okay, so this is the simulation circuit. Okay, so I'll open up my simulation platform. So I know what are all the components required for my circuit. So if I just go through, I do require some resistors, capacitors, a 555 timer, then I do require an power source and an oscilloscope. Okay, so I'll go to place component. Okay, in this I'm going to select first the resistor, say OK, and place it on my canvas. Then I'll click on capacitor, say OK. Okay, so once I've got resistor and capacitor, then I can go to sources. So wherein I can select my VCC. Okay, so it will be used to bias my 555 timer, and I do require a ground. And now I need to search for my important component and 555 timer. Okay, so I'll get it in terms of the mixed component. Okay, so in this I need to click on timer, and over here a 555 timer option, the first one. So if I click that, I'll be able to get my 555 timer. Now from component side I've selected all the components. Now left out is the oscilloscope. Okay, so I'll just place it oscilloscope on my canvas, then later I can rearrange it as per my requirements. So this is my 555 timer. So if I see my circuit, so it looks like this. I'm having a branch where two resistors and the capacitors, they are in line, and one more capacitor between the pin number 1 and the pin number 5. Okay, now I can just place all these three components onto a plane. Okay, so let me say this is my resistance R1. I want this in a vertical fashion. I'll press Ctrl R and this stands vertical. Okay, now I'll just say Ctrl C, copy of that, and I'll place it over here, and along with that I'll be having one more capacitance. I'll again say Control R so that I can place it in a vertical fashion. I want one more capacitor between the pin number 1 and the pin number 5, so I say Control C, Control V. So this I can place between 1 and 5, and this is my biasing terminal, which I can place it over here so that I can connect it to my VCC, and this I can place it to my ground of this network. Okay, and this is what I'll be using in order to view my output signal. Okay, so now if I see my circuitry, how it looks like, so I can start building a circuit wherein I can bias my VCC to pin number 8. I can just connect, okay, this pin number 8 to VCC. So I'll connect pin number 8 to VCC, and then I'll make an internal connection from this VCC to R1, R1 to R2, R2 to C, C to ground. Okay, so which completes my major portion of my circuitry. So from R1 to R2, R2 to C1, and C1 to ground. So I want one more ground over here. I'll just say Control C, Control V, so that I can place my C1 to the ground, another end of C1 to the ground. Okay, then next I need to just short pin number 4 and pin number 8. Okay, so I need to short pin number 4 to pin number 8. Okay, then next I need to connect this pin number 7, that's a discharge pin, to the junction of R1, R2. So I need to connect this pin number 7 to the junction of R1 and R2. Okay, so this is how I can connect it. Then I need to short pin number 2 and 6 and connect it to the junction of RC. Okay, so I need to short pin number 2 and pin number 6, so to connect it to the junction RC. So I will not short it directly, because if I short it then I'll not get any end terminals. Okay, so that I cannot move ahead. So now I can short this easily. Okay, then after this I need to connect my pin number 1 and 5 via the ground, and wherein the pin number 1 will be grounded. Okay, so I need to connect this between pin number 5 and pin number 1. Okay, and also I should take care that pin number 1 is grounded. Okay, then once if the circuitry is built properly, then I would like to see what's the voltage, output voltage, and what is the voltage what is being seen across this charging discharging capacitor. Okay, which assists the 555 timer to change its input potential. Okay, so I can connect my output at channel A, and I can connect this channel B to the charging discharging pin of this circuitry. So if you want, I can get it down so that there is no ambiguity. So both the channel, the other terminal has to be grounded. So I'll just connect channel A and channel B ground terminals together, and I'll just see to that a proper ground is being given to both the ground terminals of this oscilloscope. So now I need to fine tune the circuit depending upon what values I have designed for these components. Okay, so this is R1 is 2.2K, 5.6K. So this is 2.2K. I'll double click on that and set it to 2.2K, and the value of R2 is 5.6K. The value of R2 is 5.6K, and the value of C1 is 100 nanofarad. Value of C1 is 100 nanofarad, and between 1 and 5 I'm having 10 nanofarad. So this is 10 nanofarad. Okay, and the biasing voltage is 5 volts, so no issues in updating it. Okay, so once all the values have been set, then I can just run the simulation to see what is the output voltage. So I'll just click on run command, and I can double click on my oscilloscope to see how is the nature of my output. Okay, so if I just increase the scale, okay, to be more specific, if you want to see this same graph onto a plotter or a grapher, then I can just show you one more method of viewing your output signals. Okay, I need to place same scale on both channel A and channel B, so that you can understand the concept very well. So if I see your signal over here, so consider the signal. So this is your 1/3 of VCC, so it can discharge minimum to a level of 1/3 of DCC, and it can charge to maximum of 2/3 of VCC. So when 1/3 of VCC and 2/3 of VCC are reached, the output changes its level from VCC to ground, and ground back to VCC. So this is how it is vibrating between the two potentials, a ground potential and one more potential as VCC. So as I was saying you, there is one more method how you people can witness your voltage signals. So there is a grapher tool over here. Okay, so just click on this grapher tool. So as already some waveforms are presented, what's the waveform what you're seeing on the oscilloscope. Okay, if I run it, then a fresh simulation starts. So you can see here, so here you can maximize yourself. Okay, and if you want, you can place a grid so that you can easily witness that starting from your origin, so from 1/3 of VCC to 2/3 of VCC, when a signal is propagating, your output voltage is moving from 0 volts to 5 volts. Okay, because your biasing voltage is 5 volts. So this is how it is building your output voltage like a square pulse. Okay, and this is the one which is being seen across that capacitance C1, a charging discharging kind of a concept. Okay, so this is what is for this session. Okay, thank you.